All right. So section 9, we're going to look at some more numerical summaries for distributions. So we've already talked about if it's symmetric, you need to use mean and standard deviation. If it's skewed, you need to use median and IQR. So we're going to explore some more about shape when we go on the next slides. We're going to familiarize ourselves with these measures and what they mean in some different data sets. So I want to find, so for mean, we're going to use is the measure for a symmetric distribution. So for mean, to find the mean, we're going to find the average. So to find the average, you're going to add everything up and divide by how many you have. So the presiding judge for the U.S. Supreme Court is called the Chief Justice. Consider the ages of the first 6 Chief Justices at their confirmation for age of 44, 56, 51, 45, 59, 56. I want to find the mean age for the first 6 Chief Justices. So I want to add all those together. So if I add up all these numbers together, I'm going to get 311. And if I find my average, if I divide them up and divide by 6, I'm going to get an average of 51.8 years for their average age. So now I want to find the mean age for the most recent 6 Chief Justices. So if I do the same thing and look at these most recent 6 Chief Justices and do the same thing, and and I want to find their average, if I add them all up, I'm going to get 372 divided by the 6 of them. I'm going to get an average of 62 years for their average. And then it says you have just found the numbers to represent the center. So your center is going to be your typical age. So anytime we talk about center, which we're going to talk about typical age, it says complete the following to compare the two groups. The first 6 Chief Justices were typically about 52 years old, while the 6 most recent Chief Justices were typically about 62 years old. So the most recent 6 Chief Justices were typically older than your first 6 Chief Justices. Okay, now we're going to look at standard deviation. So with mean, so your mean, that is the measure of your center. So the mean always goes with your standard deviation. And so the standard deviation, we say, is a measure of your variation or your spread, whichever one you want to call it. So now let's look at how we might measure the variation or spread of our data set. In other words, we need to find a way to measure how the data measures the values varies from one to the other. So the most basic way that we measure variation in a data set is to measure the overall range. So right now we're just going to measure the range. It says when we first look at graphs, we talked about the overall range. So that was before we were kind of looking at specific standard deviation. We looked at range. It says, for instance, we might have said the ages of the first 6 Chief Justices ranged from 44 to 59. So this was before we had a specific way to talk about standard deviation. Now we will calculate the range of measuring distances between the largest and the smallest values in the data set. So we're going to do that talking about standard deviation. It says, let's calculate the ranges for our Chief Justice sets. And so it says for the first 6 Chief Justices, the minimum age was 44, the maximum was 59, and the range was 15. So for our recent 6 Chief Justices, our minimum age was a 56. If you go back and look at your data set, the maximum was a 69. And so the range for their most recent 6 was 13. So it says complete the table for the most recent 6. It says write 1 to 2 sentences using the range for the most 6 recent Chief Justices. Okay. So it says Okay, I'm trying to do it. Okay. The groups. Okay, it doesn't want to let me type. Okay, never mind. Groups had similar age ranges. The first 6 Chief Justices had ages spanning a 15-year range, and the most recent 6 Chief Justices had ages 13 year range. Oops, I can't spell range right. Range. So then the biggest problem with talking about range, about variation, is that it ignores how the values in the middle are distributed. So we need a more inclusive way to talk about how the data is spread out. So instead of continuing to use range, we're going to learn a better way to describe variation by considering how far our data is spread out from the center. So that's when we're going to talk about standard deviation. Okay, so now here they're giving you a dot plot. Okay, they're giving you a dot plot of the 2 sets of Chief Justices. And they drew the mean age with a vertical line. It says, you found in problem 4 that these groups had similar age range. Now let's look more closely at how this data is spread from the center. Which group had data that was spread farther away from the mean? So if you kind of look at your graphs, okay, so if I kind of look at this, let me get my pen. So this one, this graph here, if I kind of look, my data here, okay, so this one here, my ages are spread far from the center. So my ages, for the most part, except for this one, so my ages are spread far from the center. Whereas in this one, most, except for these two, my ages are close to the center. So it says, which of the Chief Justices groups had ages that were spread farther from the group? Okay, so the ones that were spread farther from the group were the, that was the first 6 Chief Justices. We say this group had more variation. So this is the group that had more variation because they're spread out farther apart. We say this group has less variation because they're closer into the center. Okay, so 6 says record the mean age of the first 6 Chief Justices from problem 1. So the average was a, oops, I need a pen, 51.8. And so then it says we'll look at how far each data value deviates. So deviate means like how far they are from the mean, how far they are from the mean. And the difference in the value is called a deviation. Find the deviations for each mean. So we're going to do 56 minus 51.8, 51 minus 51.8, 45 minus 51.8, 59 minus 51.8, and 56 minus 51.8. So that, let me change my pen color, is going to give me 4.2. Now be careful, some of these are going to be negative, some of them are going to be positive. This is negative 0.8, negative 6.8, 7.2, 4.2. So you might pause it for a minute and copy this down. Number 7 says, consider the deviation for age of 44 years. Write a sentence to interpret this deviation. Why is it negative? So they want to know this one, why is that negative? So this age, it's an 8. So this age is 7.8 years below the mean or average age. All right, 8 wants to know which one has the closest mean age of 51.8 years. And if you look, that's going to be 51 years because that one is the one that is the negative 0.8. That's the one that's closest to 0. Which one is the farthest? That is going to be the 44 because that is the negative 7.8. So the negative or the positive don't matter. What matters is the size of the number. And then it says to measure the variation in a symmetric data set, statisticians look at how far the data values are from the mean. You found in the previous problem the deviation can either be positive or negative. However, we always will describe the distance as a positive number. Which of the following statements best describes the deviations as you found in the distance above? And so the ages of the first 6 Chief Justices were typically about 6 years from the mean. So if you kind of look at all the numbers in general, about 6 is typical for that one. Okay, so in the previous problem, we used a single number to estimate a typical distance of the data values from the mean. Statisticians calculate what is called the standard deviation. It's a typical distance. So we're not going to calculate the standard deviation. We're going to use technology to calculate it. Now, normally we would have had to use section 7 to calculate, have MyMathLab calculate standard deviation. However, in MyMathLab, I listed the standard deviations that you will need for a few homework problems, so make sure that you check those, or I will give them to you. You will not have to calculate them. So this 110 says the standard deviations for the ages of the first 6 Chief Justices is 6.24 years. That tells us that the ages of the first 6 Chief Justices are typically 6.24 years above or below, so either plus or minus the mean age. Explain how 6.24 years is reasonable value for the standard deviations you calculated in problem 6. So some ages are closer, some ages are farther, but it's a typical distance. So some are closer, that's an L. Some are closer, some are farther, but it's typical. So some are above, some are below. Okay, suppose that the standard deviations for the most recent 6 Supreme Court Justices 4.24 complete the following, comparing the two groups. The age of the first 6 was 6.24. The most recent 6, they said up here, was 4.24. So the ages of the first 6 Chief Justices typically had more variation. So the bigger the number, the more standard deviation. Does this description go along with your pick from problem 5? Yes, because basically you had more variation when we did our picture, if you remember. Okay, what would be the distance of one standard deviation below a mean of 51.8? So the first 6 Chief Justices, remember the standard deviation is 6.24. So typically one standard deviation below means I would be doing 51.8 minus 6.24. So that will give me 45.8. 45.56. And then one standard deviation above 51.8 plus 6.24 would give me 58.04. And it says mark these on the horizontal axis. So let's see, 58.04 would be about right here. This is one standard deviation above. So this is one standard deviation. Above. And then 45.56 would be about here. 45.56. And so this is one standard deviation below. So in a regular statistics class, if you take it, you'll find that when you do statistics, they have something called a 68, 95, 99.7 rule that says if you go out one standard deviation from your mean between this number here and this number here, you'll find 68% of your data. And then if I go out another standard deviation, you'll find 95% of your data. So right now, between this point right here and this point right here, these 2 points and this point should represent about 68% of my data. But you don't need to know that. But basically, from my mean, if I go up one standard deviation or below one standard deviation, you have about 70% of your points. And in this case, I mean, it looks like there's half of them, but it should be a little bit more in general. But all they want you to do is go up one standard deviation and down one standard deviation. That's it. Okay. Consider the graph at the right showing the distribution of a sample of a community college baseball player. The mean weight is 193. And they want to know what is the most reasonable choice for the standard deviation of this data set. So if it was 0 pounds, that would mean everything was stacked right here. Every single point would be in here. So 0 pounds is out. Oops, hold on. Let me get the pen back. So 0 pounds is out because everything would be in one spot. 2 pounds, basically you would have a majority of your data right here and right here. You would not have this much data over here and this much data over here. So pretty much 2 is out as well. And then 20 pounds is too much because if I went up 20 pounds from the 193, so 193 plus 20 would give me about 213. That would be right about here. And then 173 right here. That is way too much of your data. That's a majority of your data right here. And you don't want a majority of your data. You want about a middle of your data. You want kind of maybe like a middle ground of your data. 20 pounds is too big. It's just too much. And so the 20 pounds is out as well. So the 10 pounds is most reasonable. So if I go 10 pounds up, that's about 203. If I go 10 pounds down, it's about 183. That seems about reasonable to have a standard deviation to have a good majority of your data. So 10 pounds for a standard deviation is reasonable. Okay, and 14, it's important to note that the context is crucial for interpreting whether a data set has a lot of variation, a moderate variation, or not much variation. So suppose a youth soccer team has a mean age of 7 years with a standard deviation of 2. Now suppose a professional team has a mean age of 23 years with a standard deviation of 4. So which team has a larger variation of player ages according to the standard deviation? So if I look at the standard deviation, you're dealing with, you're dealing with the professional players. The professional players. So a statistician who loves soccer is reading the above description and comments, how unusual. There's a lot of variation in those ages. To which data set is she likely referring to? And so to that one, she's referring to the youth.